So this is part 2 to my Weierstrass substitution video, and I've already done the substitution. So this was cosine of x, this is 1 plus cosine of x. So I've got the original integral here, and I'm just showing what the substitutions are in terms of polynomials of t. And then my differential of x is equal to 2 over 1 plus t squared dt. Now let's start this, because this integral is actually, lengthy, and it involves a few little neat tricks, man. So, alright, we've got this constant of 2, it's a constant multiple, so we can bring it out the front of the integral. So it's 2 times the integral of, let's rewrite it again, 1 minus t squared over this dude here, 1 plus t squared, over, let's kill two birds with one stone, man. So let's make a lowest common denominator here, because this is 1 plus 1 minus t squared over 1 plus t squared, so to multiply both sides by 1 plus t squared to get a lowest common denominator, yeah? So this is just 1 plus t squared, and this is plus 1 minus t squared over 1 plus t squared. And then that's still being multiplied by 1 over 1 plus t squared dt. Cool. Now what? Well, these guys can cancel. Can you notice they're the same, man? I can cancel them out, because this guy would have gone to the top, yeah? And then these guys would have cancelled anyway. So now we have 2 times the integral of the same thing, 1 minus t squared over 1 plus t squared. And then that's over, well, what's 1 plus t squared plus 1 minus t squared? Well, I've got a minus t squared and I've got a plus t squared, so that's cancel. And this is just going to be over 2, because 1 plus 1 is 2. And you know what's funny about that? How beautiful is that? These guys cancel too. So now I literally just have the integral of what should have been just cosine of x. So now I have the integral of 1 minus t squared over 1 plus t squared dt. Now this looks hard. You'd think, oh, maybe I should split this into a difference of 2 squares, because 1 minus squared can be written as 1 plus t squared, 1 plus t, 1 minus t. Don't do that, man. What you got to do, you got to split the fraction here. So this is the same as the integral of 1 minus t squared plus t squared minus t squared over 1 plus t squared dt. Now I'm going to pick and choose what I want to do here. So this is equal to the integral. I want 1 plus t squared in the numerator as well as the denominator, so they can cancel. So I'm going to take this guy and this guy. So this is 1 plus t squared over 1 plus t squared dt. And then I've got a minus t squared and a minus t squared. So that's minus 2t squared. So this is minus 2 times the integrals. I can bring the 2 out the front. T squared over 1 plus t squared dt. Well, I know that this is just going to be equal to 1, and the integral of 1 dt is just t, so t minus 2 times the integral of t squared over 1 plus t squared. Cool. Well, I have to split the fraction again, but this will be the last time, I promise. So this is why this is tricky. So this is plus 1 minus 1. So this minus 2 is going to be in front of the whole integral. Just try and make note of that. So the integral of t squared plus 1 over 1 plus t squared dt minus the integral of 1 over 1 plus t squared dt. Close the bracket. Cool. Now that looks tricky. Not really. This is just 1 again. So this is t minus 2t, yeah? Because the integral of 1 is just 1 dt is just t. And then this is minus 2 times minus 1, so that's plus 2 times the integral of 1 over 1 plus t squared. But this is the same as the integral of 1 over 1 plus x squared dx, which means that this is just the arctangent of t. So this is plus 2, the tangent to the minus 1, I hate saying that, plus c. Okay, cool. Now we make our substitutions. T was the t was tangent of x over 2. As if we remember our right triangle, it was basically like this, yeah? So x over 2, this is t, this is 1. So the tangent of x over 2 is t over 1, which is just t, yeah? So that's just tangent of x over 2 minus 2 times the tangent of x over 2. So minus 2 tangent of x over 2, because that's just t, plus 2 the arctangent of t. Well, if I know that the tangent of x over 2 is equal to t, then x over 2 is equal to the arctangent of t. So then that means I've got plus 2 arctangent of t, which is just plus 2x over 2 plus c. But these 2's cancel, and then I'm left with, well, I've got a minus 2 and tangent of x over 2, and I've got a plus 2, I've got a plus 1 tangent of x over 2, which means that I've just got minus tangent of x over 2. But I'm going to write this as x, because this is just x, minus the tangent of x over 2 plus c. And that is the final answer for this integral. So this is literally just an introductory example, and you can already see how long it takes, how many steps there are, and how tricky the integrals get. So if you're new to integration, you should probably start somewhere else, but these are fun, dude. Anyway, see ya.